In this video we will illustrate how can we measure non-stationary signals with an advanced spectrum analyzer. This is the instrument we will use, the Keysight MXA N9020B signal analyzer. We also need a generator able to provide a signal with a non-stationary spectrum. We can use our mini-circuits generator for this purpose. I will apply to the analyzer a sinusoid with a time-dependent frequency. To do so, I use the sweep mode, select frequency sweep, and specify a frequency that changes from 1450 MHz to 1550 MHz with steps of 10 MHz. The signal will keep the frequency constant for only 10 milliseconds. This is a bit challenging for a conventional spectrum analyzer. The usual plot is not very helpful now. Let us tap on the Window tab and choose the view called Spectrogram. OK. The spectrogram enables us to monitor how the spectrum changes with time. Let us check how this measurement changes with the resolution bandwidth. Let us reduce the bandwidth. We are going to specify 100 kHz. The plot changes noticeably, and let us reduce even more. For instance, 10 kHz. It becomes impossible to monitor any time dependence. It is interesting to compare the two bandwidths that enabled us to observe spectrum changes. At 910 kHz we could observe the dynamic behavior of the spectra, but with this bandwidth the estimation of the true frequencies of the signal becomes more difficult. If we reduce the resolution bandwidth, we can improve the estimation of the frequencies and even reduce the noise floor. But then the measurement becomes slower and we start to miss details of the time evolution of the spectrum. If we try to tune the configuration parameters, we might improve the spectrum visualization a bit, but we really need something different for this kind of spectra. And we got it. It is the real-time spectrum analyzer function. Let us check how it works. I tap on the plus icon and this duplicates the view. Now I tap on this tab again and specify the mode Real-Time Spectrum Analyzer. The visualization of the signal clearly improves. Let us come back to the configuration of the generator in order to understand this spectrogram. We might do a detailed cross-check with the markers, but this time it won't be necessary. The improvements we found are quite obvious. We applied to the analyzer a sinusoid with a frequency changing from 1450 MHz to 1550 MHz in a step of 10 MHz. Each frequency is kept for 10 milliseconds, as we said with the dwell time. Therefore, the time interval between two sinusoids of a given frequency will always be 100 milliseconds. Finally, we set a power of -50 dBm, and this value agrees well with the one we obtained with the color scale we are using.